So hey guys, my name is Garland. I'm part of Managed Kube. We're a consulting company. We're a small consulting company doing Kubernetes stuff, building infrastructure and things like that. And then what we also do is, you know, uh, maintain some open source projects where we think is helpful for the wider community, just like the one that I'm about to present here. So let me share my screen. So this project is called Kubernetes Common Services, and it's on GitHub. It's public, and it's a combination of services, right? So why we're doing this is that what we've found throughout our times, the years in helping people stand up Kubernetes cluster, running Kubernetes cluster, is that it's kind of hard to run Kubernetes clusters, and then it's hard to run items inside of Kubernetes clusters. So I kind of presented this project last week in the virtual meetup, so I'll kind of briefly go over this. And then this session is really to jump into the tutorial, the demo, and get into the hands-on-ness of it. So really, so what this project is about is that it takes a little while for you to get your Kubernetes cluster up and running, and there's a lot to a Kubernetes cluster, right? Like, how are you going to build this Kubernetes cluster? How are you going to maintain its life cycle? Are you going to terraform it up? Are you going to use EKS-CTL? Are you going to use COPS? Are you going to use GKE? And if you use GKE, how are you going to instantiate that GKE cluster? Are you going to go on the GUI and click a couple of buttons, or are you going to write Terraform to instantiate this thing so that you can create a dev, staging, prod, all the same, et cetera, et cetera. So that's a lot to take care of already, right? So once you have that, it's like, cool, you have a Kubernetes cluster. And ultimately, you really just want to get to this blue part, right? Like, this blue part is your application. Like your API, your UI, whatever application that you're running on Kubernetes cluster. However, you got to do all this other stuff around it. For example, getting your Kubernetes cluster up and running. And then once you have that up and running, before you even get to your application, you need to stand up an Nginx server. You probably want HTTPS. So you want certificates. Do you go buy certificates and put it into your Kubernetes cluster, or do you use something like a free Let's Encrypt cert? And then also like setting DNS, right? Like, so when you're exposing API or a web thing, you want people to get traffic into there. And then so your DNS has to point to here. And then so these load balancers, these cloud load balancers are usually dynamic, right? Like when you create the Nginx-ingress, and which you create a service type load balancer, it creates this load balancer. And these things are dynamic and it could change. So do you go manually set the DNS and point to this cloud load balancer, or do you have something like external-dns to handle it for you, right? And then so Kubernetes ecosystem is pretty fantastic. It has a series of open source projects like external-dns, seal secrets for encrypted secrets, Prometheus for metrics monitoring, Grafana for dashboarding, Loki for logging, Elasticsearch for logging, scaling, via Prometheus metrics, cert-manager to get free Let's Encrypt certs, Nginx-ingress, which handles your ingress controller and Nginx. So this is just a very small list, but then Kubernetes ecosystem has a lot of tools to help you run your application, right? Like this blue part. However, running all this green stuff in here is also non-trivial because you have to kind of know how to use it, know what it's using for, how it's configured, and then how does it play with other apps, right? Because like Nginx-ingress can expose metrics that you can say, oh, how many 400s or 500s, 200s I'm getting, and you can view that in Grafana, but then that you can't enable that until you've enabled Prometheus with the service monitor, CRDs and stuff like that. So there's a whole slew of integration that needs to happen here, right? that before all the screen part is kind of working nice and neat. And then so you can just basically plug your, blue part in and spend time on that. So what this project is about is that it's here to help you integrate and deploy out all of this green stuff so that you can get to your blue part and then focus your time on that, because that's the real value add, right? Like you learning and running these items is really not value add to your infrastructure and really, your time, right? Your time is best probably spent over here in this blue part. You as a DevOps person or someone that maintains this probably just had to do all this stuff because you needed all this stuff there. So yeah, so this project is here to help the integration, help testing to make sure that ongoing this stuff keeps on working, and then an opinionated method of actually delivering this stuff into your cluster. So as we go down, you can read about all of this stuff yourself. I'm not going to go into fully on what this stuff is, but for the first iteration of this, we've chosen Weaveworks Flux for the CD mechanism. And this is a GitOps workflow, right? What Flux does is it watches your repository like this one here, and it watches the files in here, right? And then when there's a change in the file and a new thing comes in or a thing disappears and delete it, it will apply that to Kubernetes, right? So be it a Kubernetes YAML for deployment, for a service, or whatnot, it would apply it to Kubernetes. And then there's also, Flux also has these custom resources definition that will allow you to instantiate Helm charts. So you can create these things that Flux call Helm releases, which I'll show you in a little bit also. And then that would be applied on the cluster. And then there's another Weaveworks Flux Helm operator that operates on this resource. So don't worry, I'll show you these resources in a bit, kind of get hands-on to it. But basically, it would instantiate your Helm release and then deploy it into your cluster. So this is nice because we don't have to build a pipeline or run this thing somewhere like on Jenkins or Circle CI or GitHub Action. This Flux CD thing actually runs in the cluster that you want it to deploy in. So if you had a dev cluster, you would run this Flux CD thing in the dev cluster. If you had a staging or a product cluster, you also run it in there. And it will watch your repository for changes and apply it. Yeah, so the demo today is really, I'm gonna go up and set this up. So you can actually do this on your own and in your own cluster here. It'll tell you how to set up. So there's really two big steps, is install the Flux operator. And then also once the Flux operator is in there, which is this thing, and the Helm operator, then you can start checking in files into your repository, which the Flux would watch, and then it will deploy out. So yeah, so let's get started on that. So I'm going to switch over to my IDE here. Let me actually also get the chat window open. So let me also say this, is that if you guys had any questions while I'm talking, feel free to kind of jump in there and ask the question. Either get on the mic or post it in the chat. But I'm not going to be looking at the chat too often, so you might just be like, hey, there's a question in the chat or something like that. So yeah, so let's look at the cluster I have. So I'm in the repository right now, and I'm in a branch called demo. Right, and then I have a Kubernetes cluster right here. I have a Kubernetes cluster right here. It's on GKE. It has a few things on there already that's running, like cert-manager, Prometheus, and stuff like that. It doesn't have Flux running in there yet. But we're about to install this. So let's go into the Flux directory, and then let's see what's happening. So the first thing we're going to do is we have a make file here. So this project is really kind of batteries included, right? Like it walks you through the entire life cycle of it, not just the initial creation. So what we had a problem with a lot of other projects out there is that they don't walk you through the entire life cycle. They kind of take you through a demo, which is cool, right? Like, what else can you expect, right? Like, they take you through a demo and then be like, here is how it's set up. And it's like Shazam is set up. But then it might not be set up in the most secure way. It might not be set up in a way where you can check it into your Git repository and then update it later and stuff like that. And then also it might not, it's a lot of times it's not set up in a way where it's thinking that you're going to have a dev, staging, QA, and a production cluster, right? Like, it's just saying, here's how to set up in one cluster, you know, might be named demo. So what this project is also about is that it's trying to take care of this entire life cycle. It's trying to help you run this in a real production environment. So let's take a look at this makefile and like what it does, right? So this is a very simple makefile, right? Like this makefile just basically encapsulates the Helm commands. We're going to instantiate Flux with Weaveworks Flux's Helm chart. And, you know, I really don't want to memorize these Helm commands. So really what I do is I just put these into make files. And then so what's special about this configuration is that there is an environment folder right here holding environment specific items, right? So for example, if we look at the chart, there's two values file that we're gonna enter into this to create Flux, right? Like, so if we look at this, we're gonna add in the values file here. So which means that it's this dev GCP one that we're on. So this points to the repository, and then it points to the branch that I want to work with, and then points to the path. So I'll get into the path and stuff later on, but then, you know, I'm currently working in the demo directory, and then so this has all the demo stuff. So I was like, hey, Flux, go watch this demo directory in this repository right here, which is this repository right here. All right. So what I do is I enter the command make environment equals GCP dev, and then in this make file there's a template action which basically runs Helm template, right? It runs Helm template, and then it outputs all the stuff. So really what I'm checking for here is that, okay, the Git URL is the URL that I've set up in my values file. This is the branch that I wanted. This is the path I wanted. Everything else is basically default setting that it comes with, right? Like, I don't really care what it did there, as long as it works. So all of this stuff has been tested already, so it works. So I'm gonna apply it, right? So since all of this stuff works, you can actually just clone out this entire repo, right? And change a couple of variables, such as the repository. You know, you're not going to use my repository because you don't have access to it. But if you cloned it out, you know, you'll point it to your own repository, onto the branch that you want to play around with, and so forth. So that just deployed. And then, so the next thing we're going to deploy is the Helm operator. Well, actually, let me take that back. The next thing we have to do is actually give this Flux access to our Kubernetes repository, right? So there's this make command that says get identity, which is really running the Flux binary and the command identity. And what this returns is it goes to your Kubernetes cluster, looks for the Flex pod, and it outputs the public key to, it's generated a private key and a public key. So you put this public key and you go into your repository, right, setting, you want to go deploy keys. Let's delete this deploy key and we'll add in a deploy key. So what this deploy key does is it gives access, Flux that was just deployed into your cluster by running that make command, access to this repository. So now it can come over here and read this repository. If it was, you know, this repository is public anyway, so it can read it. But let's say you had a private repository, then giving this this would give access to this repository. And also give it write access because there's additional Flux functionality where you can give it write access. And then, so that has been deployed and I gave Flux access to my repository. And then, so now the next thing I gotta do is deploy out the Flux Helm operator. The Helm operator releases Helm charts. So I have another directory that has the same, you know, the same kind of content, has a makefile, has an environment, and things like that. So I basically run this same command again, but in this directory, and this time it's gonna install the Helm operator, right? And once it's installed, I can show it to you in kubectl. Okay, so now it's been installed into a namespace called Flux. So there are these things that we just deployed, right? Like, so Flux, this is the Flux operator, this is the Helm operator. And then we can look at the logs, right? And see what it's doing. So it basically went over to my GitHub user, and then it downloaded it and then it started doing some stuff, you know, it's applying and things like that, right? So cool, so it's working. So the next thing, I'm gonna close these files out. The next thing we wanna do is now, so this demo is I'm gonna deploy out external-dns, I'm gonna deploy out Nginx-ingress, and then I'm gonna deploy out an HTTP echo server so that we can hit this thing from the web. All right, so we're gonna get pods that says all namespaces, just to make sure again that I'm not cheating you guys. There's nothing in this cluster with Nginx-ingress, the HTTP echo server, or external DNS, right? So let me show you what we're about to apply. So since this is a demo, I have all of the files kind of prepped up already, right? So let's look at this. This is external DNS Helm release, right? So this is the thing that I was talking about that was the Flux CRD, which is a custom resource definition. So you can apply this and then Flux knows how to handle this kind. So what this kind is saying that is external DNS chart has a version, and then it has values that we're providing it. And then, so this cluster is on Google. So we're deploying an external DNS, external DNS goes out, reaches out to your DNS provider and syncs the DNS names that you have in ingresses or services based on the annotation to what your load balancer is. And I'll show you the load balancer IP once we have instantiated the Nginx-ingress. But basically, we're telling it what DNS provider we're on, and then also the secret, right? Because external DNS needs access to your DNS provider to be able to make changes, because not anybody can just make changes. So we're actually using sealed secret here. And with this being an open repository, I'm, okay with checking this stuff in. So this is an encrypted secret. So you can't decrypt this without the appropriate key. So this is all right. This is fine to check into even a public repository, right? If you wanted to go and brute force and hack this thing, be my guest. But it's going to take you a while, and I'm not that concerned about it, anyways. So here's the secret, and it's a sealed secret. So the sealed secret, I'm not going to go into too much detail about what sealed secret does, but sealed secret is an open source project from Bitnami, which basically allows you to encrypt and check in encrypted secrets into your repository. And then the private key to decrypt it is on your Kubernetes cluster. And then sealed secret has a controller that changes this into a Kubernetes secret on your cluster. So what I'm going to do here now is I'm going to copy this external DNS stuff into the path, right? Because we said the path was going to be for Flux to watch this Kubernetes Flux releases GCP dev. So dev is really my cluster name. So I can have dev, QA, staging, prod, and then I can tell it to watch a certain directory structure, and then that is what will be installed in there. So currently, cert-manager and all these other things are installed on there because when we start Flux, we told it to watch this directory, and it's going to go and sync all the stuff. So now we're just going to add a few more things to it. We're going to add this external DNS, this Nginx-ingress, and this HTTP echo. But however, we'll do it one at a time first. We'll do this one at a time, and then I'm going to go run through how to check to see if everything is okay, and did Flux actually start the stuff up. So what I'm going to do here is copy this external DNS folder and place it into this dev folder. So the same content is in there. So if we look at it, we just added that. So this is a Flux GitOps kind of workflow, right? So usually you don't have to go, usually you should not have to go and use kubectl and make sure everything's working and all that, jazz. But, since this is a demo and I want to show you what's happening behind the scenes, I'm going to go do the kubectl. But usually your workflow should be like, oh, I want to add the external DNS. And then you copy it over there, and then you go git add dev DNS, and then you go git status -s, and you'll see that, git, you added the file. So there's nothing special, right? This is all git stuff. So I'm going to git commit adding external DNS. And then I'm going to git push it into this demo branch. So usually now I would just have to sit around and wait until Flux decides to re-up again. So Flux, by default, I believe, looks at rechecks, resyncs on the repository like every 5 minutes. And I'm kind of impatient, and this is a demo. We don't want to sit here for 5 minutes. So a little trick is you could delete the pod, and then it'll start back up again. And then on next startup, it will re-up on the repository again. It will go download the repository again and then reapply everything again. So it downloaded it, and then so you see this output right here. It's kubectl applied all of this stuff, which is basically all of this stuff in this directory structure. And yeah, so I guess the logging could be a little better, but then we should see something here with external DNS, but I don't see it right now. But we can then just git pause all namespaces. And there's nothing there yet. All right. So now it's time to troubleshoot. There is one thing that I forgot to change, is that this repository is also using customize, and we have to tell it to go and watch that directory. So I won't get into customize too much right now because it is like its own topic on its own. But however, you have to tell it to go and watch the directory, customize to go and customize the directory that you want it to instantiate also. So we look at this, that's cool, git commit, adding external DNS. And then, so we'll do the same. We'll go delete this pod. And then we'll log out this pod, this new pod that started up. And see if it did anything this time. So one thing you're looking for is this error equals null. Null for error in this case is good. And then do we see? Okay, so we do see external DNS here now. So that is sounding okay. Okay, so it did spin up a pod. But let's look at what happened there, right? Like, so it deployed out this Helm release, so we can actually look at this Helm release. So git HR is a shortcut for git Helm release. So this was created 48 seconds ago, which corresponds to about when I restarted the Flux thing. And then we can describe this HR. And basically, it's the same content right here that is applied here. So it's like, cool. It's a good check to make sure, be like, okay, cool, Flux actually applied what I had here into my Kubernetes cluster. External DNS, from the open source upstream, open source external DNS chart, my settings on what domain I wanted and stuff like that. Setting memory limits, et cetera, events saying that the Flux release operator, right, said release this thing and synchronize, everything's good, there's no errors, which is cool. So that's basically what we want to check out, and then we would get pods. We see the pods here, and so that's cool. So the next thing we can do now is deploy out Nginx and HTTP-ingress. So I'm just going to copy both of them in here and checking them at the same time. Right, because this is basically rinse and repeat now, since we know what to do. And then so we copy them over here. We have to go and tell customize to go and customize it, because if you look at this Helm release, it's not the full Helm release, right? Like it's actually partial, and then there's a base that has the additional information, like the chart name, the chart repository, the chart version, and then you saw that there were these resource limits that were not in the GCP dev external Helm release file, because the base has this information. And then the base is sourced, you're templating here. So really the base should be applied to every single environment, be it AWS or be it dev or be it GCP dev production. These are the base values that you're having. And then these are just really the override values. But yeah, so customize is a whole nother thing. We'll probably have another session on that. So what we have here is we're going to add in dev echo. Oops. We add in echo server. We're going to add in the ingress. And then we see the customized file change. We're going to commit this in, adding in nginx-ingress and HTTP echo. And then I'll push this into the demo branch. And then the same thing, I'm going to go over to the Flux namespace, and I'm going to delete the Flux pod because I don't want to wait around till it kind of resyncs again. So delete it, list the pod, same thing here. I'm going to look at the logs. And then I'm going to search. Well, so I don't really even have to search. So the last thing, it says the echo server. So cool. Once again, the error equals no. That's cool. We don't want to see any errors there. We see the HTTP echo server being deployed out. We could get pods --all namespace. And then we see the ingress being deployed out 18 seconds ago. And then we see the HTTP echo server being deployed out also. So we can do the same thing, right? We can check up on the ingress. So we get the HR, which is the Helm release. It was successful. We can describe the HR. It's just a bunch of settings. I'm not going to go through the settings, but what we're looking for here is really that there's no errors in the event that's reported by the Helm operator. And then we can get the services. So here is the public IP address of the load balancer that, that is spun up for me in GCP. So that's cool. It looks like everything is good there. So get namespace, let's look at the HTTP echo server, get ingress. Right, so the ingress is this. So we can look at the HTTP server a little bit closer. So as you can see, the HTTP server is just a bunch of YAML. It's not a Helm deployment of anything. So it has an ingress, and then this ingress is saying that it's going to use this Nginx external class, which that Nginx-ingress we deployed is listening for. We also have the annotation for the external DNS. This is the annotation that you had to put on so that the external DNS knows, be like, okay, cool, this ingress, I'm going to go act upon this ingress because you've put this annotation on there. And then I'm going to take this name and then match it up with whatever ingress this was associated with, which is here. So this name, we can actually look at this name and see. So we should see that this name comes out to be 35.226.184.209. So we dig this name. Looks like external DNS did its job, and then we can actually go to this server, and then this echo server basically just echoes back the headers and stuff like that you put on in there, and then we can go like foobar, and then you guys can hit this too, right? Like this is a public thing, like it's just sitting out on the internet, and then so we can see the foobar path. And then so we can actually get the logs of this thing, of the HTTP echo server, and see that it came in. See, there goes my get for the foobar from my Firefox browser. So we know that it kind of transversed through the load balancer and then into the Nginx-ingress, and finally it hit this pod here, because this log, kind of shows us that. So yeah, so this was a demo. It was kind of pre-cooked a little bit, but then for you to get kind of started on this, wouldn't be too much more difficult by using this project, right? Because this project kind of sets up all of the directory structure and things for you already. So like if you were on AWS or GCP, it sets up standard secure by default kind of stuff. It makes some assumptions on what you want, and the kind of the easiest path to kind of get there. Yeah, so if you can even see that, so this is all GitOps kind of workflow. So you can see that everything that we've kind of done here, right? So we've kind of, since this is demo early on today, I've kind of tried out, removing all this stuff and adding it back in, and then I removed it all. And then so these were really the adding back in that we just did, right? Like this is a public repository. You can go and look at this commit structure yourself. So it really gives you a way to kind of audit this stuff and see what everything you've done was there. So yeah, so that is the demo of going from 0 to GitOps with Nginx, external-dns, HTTP, echo proxy, echo server there for you. Yeah, so that's kind of all I had today. Does anybody have any questions? Feel free to put it into the chat or just unmute yourself and kind of ask some questions. There are no questions. I do have another survey, and I posted a link to another survey. So this survey is really asking for feedback around this project, what you would like to see in this project, what you think is useful, what is not, etc. Yeah, so someone said, I guess you don't have the SSL deployed. So cert-manager is there, and it is deployed out. For this demo, let me share my screen again. For this demo, I kind of foregone using it because sometimes it takes time to get the cert and stuff like that. But if I'm looking at touring get ingress, I can go to this Prometheus, and there is HTTPS here. And this is a Let's Encrypt cert, right? So this is a Let's Encrypt cert that will expire on July 18th. But there is git possession all namespace. So cert-manager is running on here for this HTTP echo server. I just didn't add in the cert because that can take a while for a demo. It might not come through, etc. But this project has the cert-manager and stuff like that included. And also taking feedback on what else you would like to see in this ecosystem, right? Like, so I know that this is a set of opinionated, items. I'm happy to add in more items. If anybody has any feedback, suggestions, let me know. Always trying to integrate more stuff into this. So yeah, I'll be sticking around for a couple more minutes. You know, if you had any more questions, feel free to ask. All right, that's it.